Right, good. Good morning and welcome, everyone. My name is Sandeep. I'm one of the principal engineers at Amazon. I have with me Carl Roth, senior software developer at Amazon, and Larry Ho, VP of engineering at Edgecore. The three of us are here today to talk about the adoption of SAI in the Dent program. We will introduce you to the Dent program, its current architecture, the changes that we're making to add support for SAI in Dent, and provide updates of the progress that we've made so far and what to expect in the next 4 to 6 months. With that, Larry.
Okay. Good morning, everyone. There was a Dent mini summit yesterday morning, and what I want to make sure is for those of you who did not attend, I'm going to repeat some of the messages introduction on Dent to give you some background before we jump into the topic, which is the SAI integration. Just a little kind of restate the mission of Dent. The Dent program, the project under Linux Foundation, was formed about three and a half years ago. And like any Linux Foundation project, it has a set of common missions. And then Dent also has its own enhanced specific missions that we want to focus on this project. So rightmost, we want to form this as an ecosystem. Dent is not just a NOS. Let me reemphasize that. We started forming this with the intention that eventually we want this to be adopted as an open source product, not a black box product software. And so to do that, we also looking at some of the Linux Foundation, other foundation projects, and learn from the improvement areas from some of those projects. And we came to the conclusion that user participation early in the project is very, very important. We do not want this project to be dominated by vendors. And so we wrote it into our charter, in our mission, and been carrying through that throughout. And second of all, it is an ecosystem. So therefore, you want to take care of this as a solution from an angle. You do not want this to be just a software development project running on some hardware. Testing is a focus in Dent. So if you look at our current subgroups, there is an end user subgroup and there is a test subgroup. That's been really the two major pillars that we formed to trying to push Dent forward. Beyond that, the neutrality, of course, is very important. We want to attract multiple ASIC vendors and switch vendors and to contribute, and software developers from all angles, and to come in and trying to build this. And so the SAI integration that you will hear in today's talk, it's a change, an enhancement in the Dent direction. Earlier this year in Prague, the last regional OCP summit, we have announced it at that time that Dent is going to incorporate SAI. And so today we'll tell you about it. And that incorporation is a big motive behind it, is to try to attract more ASIC vendors participating who favor the SAI approach as opposed to the SwithDev approach. So again, Dent is more than just an OS. So most people will now talk about it as Dent, but the actual terminology is Dent OS is different than Dent, okay? So the software part is the network operating systems, but this OS was contributed by Amazon. It is designed and architected to run more than just on a switch. It's targeted for enterprise area. The initial deployment is on enterprise retail stores, and because of that, the architecture of the OS, it can run on switches, but it also can run on gateways and on other devices, the IoT devices that are very, very important in the stores. Hardware is still the switch, and the switches are the basic, the first one that comes on the scene with Dent. But again, the IoT devices are also part of the scope of the Dent charter. We have multiple silicon vendors participating and it's contributing. And the major foundation of Dent is built on Linux. And that's why we first embraced that as a using the SwithDev as the approach to access the silicons, the ASICs, via the Linux kernel. There are pros and cons. I'm not going to go into this in this talk. But now with SwithDev and SAI both supported as a way to access the data plane and the ASICs, I believe that Dent now is covering the best of both worlds and offer a choice for deployment. Dent faces some unique challenges and some are more common challenges to other applications and networking use cases. We, in particular, on the security part, unlike data center, there are unique security challenges for stores, right? So first and foremost, when we look at the features, which I'll cover next, it is important for us to build in the security features at an early stage and start evolving in it. And because security often involves third-party applications. Example, the 802.1x, you implemented it, guess what? Most of the deployment, unless you're deploying in a greenfield, most of the deployment is in a brownfield. So you do have to test with existing third-party like ICE, like ClearPath, and all those kind of things. So it is a solution-driven approach for Dent, and so is also our testing approach. PoE, almost all retail stores and corporate networks and campus networks require that. This is another thing that's different than data center. So there's a lot of focus in Dent, putting both in terms of features and testing into PoE and also the advanced PoE control functionalities. The debugging tools, again, it covers beyond just the switches and environment and debugging. There are unique debugging when you start talking about IoT devices, gateways, and so forth. So there are a lot of those. Last but not least, there are a lot of talks even in this OCP mentioning about ONL. The fact is, I mean, it's a well-known thing that ONL right now, depends on how you phrase it, needs a replacement. And so Dent is taking the leadership to trying to come up with an alternative solution. It is not the focus of this talk, but those announcements, the literature are forthcoming, and it is something that Dent will embrace, and hopefully other software projects, other areas in OCP that has a dependency on ONL can use it as a reference. So a little bit about the Dent OS now, getting back into the OS and the NOS itself. We focus heavily in the community on testing, on quality from day one. The idea is, again, back to my vision, right? Edgecore is a founding member of Dent, and so we also participated in a lot of OCP activities. It's a little known fact that Edgecore actually was the first, one of the three vendors when OCP first came up. The very first OCP in 2015, there were 3 vendors, 3 booths, and Edgecore is one of them. And so we traveled this journey and we saw a lot of the open source contributions. Quality wasn't the focus in day one. And for network operating system, for software, anyone that do software development will learn that if you don't focus on quality in day one, it is going to be a price to pay later. So we test the test subgroup, and thank you to Keysight, a key member of Dent, have put in very intense testing test beds, real physical test beds in their labs, and make it accessible, not just for internal Dent community testing, but any users that wants to get their hands and try it out, it can be made available. So those are remotely. So those are some of the benefits that Dent is putting on. Of course, we have no software licenses, just like any open source project. We don't want to charge that, and then it is an open source community focus. On the features, a little bit quickly talk about it. It is, again, enterprise edge focus. It's not data center focus. But we started to adopt some of the FRR routing libraries in here now. So back to the testing, right? FRR is great, it's matured, but it also has its own path. So any OS, any open source project that adopt FRR is a challenge to keep up with it. If you don't sync up frequently, you're going to find yourself missing a lot of bug fixes in your own project. So we are well aware of this and keep on. So the other part, I already covered it on the security part. We put on it. Net is it's very ASIC dependent. Not every ASIC supports it, but for those that support it, we do have the software functionality. So otherwise, it's pretty much L2 focus. And so you can read, it's not just the basic enterprise deployment features. Our roadmap is actually published in the Git website. So anyone that's interested are welcome to go and take a look. We are now into the version 3. The release frequency has increased. With the community has committed to releases 3 times a year instead of once a year. So so far we've been keeping up to this promise. Okay, so.
All right.
Thank you.
Let me take a step back here and we can take a look at the architecture picture for Dent. So it's structured like a server class operating system. It's network focused. So you can see in the middle of the diagram, there's a SwithDev driver that is the network interface that's exposed to the kernel. The top of it is the normal Linux server stuff, FRR, IF up down, things like that for interacting with the network. In a traditional server with a NIC, there's source code in the kernel, it compiles against it, and it talks directly to the hardware. So with SwithDev, we're talking to ASIC vendors that don't want to provide source code. So the SwithDev talks to a firmware blob that's delivered by the ASIC vendor. So it's similar to SAI. So what we're trying to do here is we're presenting an approach where we're going to take that same interface layer, the same SwithDev layer, same network commands that you normally use in a server, and replace it with a SAI backend. So we use SwithDev as the main network interface. So it's like normal server management tools that you wouldn't need to worry about adding any more expertise. There's 3 approaches to this. So you can tell the ASIC vendor to release the source code. They're not going to do that. You can tell the ASIC vendor or plead with the ASIC vendor, please give me a firmware blob for my OS, whatever the OS is, Sonic or Dent. Or what we're trying to do here is we're trying to consolidate on a single HAL implementation so that all the network OSs can converge on that. And it reduces the load, the operational load on the silicon vendors. It reduces the test load on us. We only need to test 1 HAL. Hopefully going forward, this gives us the opportunity to bridge the devices. If you have an ASIC that works in a data center, you can put the same ASIC in an enterprise device. It uses the same HAL. It should work. It should just work. So it's roughly the same diagram for how we want to do the integration. We still have tools on the top, normal network tools that you use in Linux. There's a SwithDev driver that exposes network interfaces, and then there's a interface at the bottom that talks to SAI. So SAI runs in user space. So you can see over on the side of the diagram, there's a SAI layer that talks directly to the hardware. So we're just putting a shim there, a different SwithDev implementation that talks to the SAI. And it should work just like a normal Linux device.
All right. Thank you, Carl. So up until here was what we had announced in Prague. Like we would be making these architecture changes, et cetera. Now let's dive deep into some of the progress that we've made, the changes that we'll make to the architecture, and provide some updates. So as Carl explained, we will have a user space manager for doing the trampoline mode and using SAI to eventually program the ASIC. So we are calling it Ethernet Switch Manager. So it'll have two components, the user space agent and then a kernel module. Kernel module essentially implements a custom SwithDev driver. We don't want to move away from the TCP/IP stack in the kernel. We will use SwithDev to give us the trampoline mode for the events that happen in the TCP/IP stack in the kernel. And we use the generic netlink API to communicate between the kernel module and the user space agent. User space agent will have the ability to do TXRX with the kernel, like I mentioned. It will also have per feature modules to handle events that are happening in the kernel, eventually translate them into a language that the ASIC understands and program the register set as required. One additional thing we've done here is kept the HAL layer very flexible, which means you will be able to use the attributes that are available to you in the SAI spec, but there is always some gaps you identify or you want to do something a little differently. You do not want to be limited by the definitions that are there in SAI. So we kept the option of ability to program directly with the vendor SDK that you have, or have another stub sort of HAL that maybe per user may develop themselves, something like what Facebook and Google did, going with RIB API and some other ways of programming the silicon, which is not traditional and legacy way of programming. Diving deep a little bit more, I'll use some scenarios and signal flows to explain how the design actually is implemented. That'll give you some more idea and hopefully answer some of the questions or maybe triggers more questions. So Ethernet Switch Manager essentially, like I said, has a kernel module and a user space agent. Both of them start up per the sequence of Linux boot up, and eventually it establishes connection through the generic netlink socket, and it's ready to listen in on any of the events that happen in the TCP/IP stack or any other module, networking module in the kernel, like port events or any of the routing events or FDB, L3, any sort of thing. So it essentially sits in that infinite loop listening for events and waiting to handle them. So we'll discuss layer 3 forwarding and a layer 2 switching flow. So this is the layer 3 forwarding. Like I said, we retain the TCP/IP stack. We use the generic net tools like IPRoute2 to program the networking, to program using the standard Linux tools. It starts with there, and then eventually the IPRoute2 talks to kernel, and then we trampoline the event back to the user space agent and program the ASIC through SAI. These are pretty sort of fundamental features which are already available in SAI, so this doesn't require any sort of additional hack into using the SDK directly or any other stub HAL layer. So let's discuss some of the L2 switching or FDB updates. After programming the ASIC with the necessary bridges or VLAN aware or unaware bridges, any FDB learnt event is triggered based on a packet getting punted, which will be eventually turned into a signal through SAI that updates the kernel saying we have a new MAC address that needs to be learned, right? We are not fully sort of able to expose the kernel modules that will be used for trapping the packets or the events. That is still very vendor specific. So I'm going to just explain to you saying the control plane implementation of punting packets into either SAI or the kernel directly is outside of our project per se. So we depend on what the vendor's ability is to do the necessary DMA and capture the packets to wherever it needs to be captured. So that's the end of the technical part. So this is more about the update to the progress that we've been made so far. We'll be ready for a beta release in February 24 with the feature set of parity with Dent-SAI. The GA release is expected in Q1 24. The release will have support for Marvell's AC5X and Broadcom's Trident 3X2. We are on track to meeting those deadlines, and expect some sort of an early release in December based on what the Dent-TSC makes a decision on. The call for action, please participate with us in OCP-SAI. There are still a lot of enterprise attributes that is missing that we want to collaborate with OCP and get those attributes implemented. We submitted a 48-port converged gateway type of platform in Prague, OCP in the regional OCP summit. All the software releases that I just announced will be supported on that hardware, so please give it a try. We've also upstreamed some proof of concept drivers that you can go take a look at and give it a test drive and provide feedback or request for changes, etc. So please give them a try, and you're always welcome to try out other aspects of other things that are going on in the Dent project itself. Thanks, Ravi.
Thank you very much for the talk. I don't think we'll have time for questions. I encourage everybody to talk offline.
Okay, thank you.